Hi, and welcome to another exciting edition of CG Programming for Game Development. My name is Nate Nussler for Hyperactive Studios, and what we're going to be going over now is some more aspects of the CG language. Now, if you've been working with Unity game engine, you already know probably that you have to code custom shaders in CG. So this is setting you up perfectly if you need to write custom shaders for the Unity game engine, which has become a very popular indie game engine for kicking out games because it's very flexible and very powerful, and so allows you to do a whole lot of things that you can't do easily in some other game engines. So it's very nice and robust. It also exports and deploys for Android, iPhone, PS3, Xbox 360, the Wii, on the web. You can actually deploy it on a web page, and you can deploy it across a across the computers. So like on Mac OS X and on Windows, I believe. So everything pretty much except for Linux. Hopefully one day they'll add Linux support, but it does allow you to easily deploy across a whole bunch of platforms, which makes it very viable from a business standpoint for releasing these games very easily. And the great thing about it is once you code a game once in it, you can retarget to these other platforms with minimal work in order to actually get it to work on the different platforms, which is not the case with other game engines. So very cool, very powerful, and allows for a lot less rework, but requires some knowledge on that. Okay, so let's have a look at the CG programming language. And again, you may have seen, if you look through the overview documents, you could also have a profile in here besides just OpenGL and DirectX. You could literally have PlayStation 3 listed in here if you have a PlayStation 3 set up for development, and you can actually test your shaders on the PS3, which is nice too. So very, very cool. And this is game development, no kidding. So here we go. We got our float, unsigned float, half, and fixed. What does this mean? Okay, so we talked about float for a while here in the last video, but I'm going to break all this stuff down for different data types that are possible and allowed in CG. And then in the next video we'll start going over shader profiles. We'll go over more aspects of the language. What I've done here real quick is I've created a shader from our other example we had, and I simplified it from going from fragment and pixel shader down to just fragment shader, and have it now where we can actually change the color interactively just by dragging this around for the color picker. And so now an artist can easily manipulate our shader and change the color of it. I know it still looks ugly, but that's because we haven't added lighting, and we're doing baby steps here bit by bit until we build up to a point where it's covers it, where you can actually easily do the lighting. But that's a little more advanced for our purposes right now. We will be getting to that though soon in the near videos here. But baby steps first, by far. So float. What's a float? Well, basically this means just some kind of decimal point here, right? Like this, without the W. So something like that, right? That would be a floating point number. And unsigned float would mean, okay, so just a regular float, let's say this first, it's going to have a range of negative blah 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 to a positive, blah 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 number here. I'm not exactly sure about the exact ranges. I believe a float is a 32-bit variable here on the graphics cards, which is different than that of say C++ on your architecture for your computer. Now, I mean, there's a difference if you're on 32-bit or 64-bit as to how many bytes a single variable will be on what architecture. I mean, if you're on a 64-bit machine, float is going to be different than what it's going to be on a 32-bit machine. Whereas on a 3D card, they have their own setup. So 3D cards it has a lot more bits than what CPU has. And so for that reason, a float, they've standardized it, thankfully, across all the cards. So when you say a float, you don't have to worry about this older generation card or this newer generation card not being compatible across the different data types and having it change like it does on the CPU. It actually stays the same each time. I believe a float is 32-bit and a half is a 16-bit, if I'm not mistaken. And what that does is, then you can see why you would use a half over a float, because then it's going to allow you to have a lower precision but still get what you need pretty much. So our unsigned float is going to start at 0 and go to some big crazy number. I'm not sure what it'd be, but you're going to have a cap on how high you can go with the precision, of course. And then we have our unsigned float. We have a half, and we have a fixed. And double doesn't exist, I'm afraid. But a fixed is another floating type point where it's think of it like scientific notation, where it's like fixed to a certain range here, if you will. Yeah, something like that. Okay, and so you have your half, which is going to be smaller. And you can use these different variable types depending on performance, really. That can really determine what it is you're going to want to do as far as performance goes. If you want to do a performance analysis, you can simply just run it right here. Well, preferably where you can actually see it. It's always good. And you can see different profiles here. Fragment shader versus vertex shader, and so on and so forth. I'm probably getting an error because I have this thing right now with this laid out just to show you that these are all actual valid data types here. Let's see here, graphs. Yeah, it's not giving me anything. Yeah, okay, we'll do this in just a second. Okay, it's no problem. Alright. But over here, this is an error, by the way, what I'm doing right now, because I do have all these data types without variables assigned to it, so it's not allowed. It will cause a compiling error, no doubt about it. Without, see, yeah, definitely. We'll get into that in just a second. I'm going to comment it out so it's not an issue, and I already have it set up for that. Okay. Int is an integer. Think of it like a whole number. So, for instance, like this. That would be a whole number. There's no decimal point. There's no floating point, however you want to call it. There's none of that happening. So, that's also something you need to recognize. Unsigned int. And remember, int's going to be a negative to some positive number here. We have an unsigned int. An unsigned int is going to be basically 0 to some positive number. And basically, the reason why you're like, well, why do I care? Well, the reason why you're going to have an integer versus an unsigned int, say you need to get a bigger range, you don't care about the negative aspect to some number. It doesn't apply. Like, you're not going to have negative color, or you're not going to have, it doesn't make sense, right? So, in order to get a larger range of color and capabilities, you might use an unsigned in order to double the size, the length of what your number range is going to be. So having an unsigned int would make a whole lot of sense if you're going to be starting at 0 and going to some large number to have a better support for whatever operation you're doing in the programming language. Bool stands for Boolean. This means true or false. Now, at this point in these videos, I'll let you know when you have to have knowledge of C++. When we're starting out here, you don't have to have any knowledge of C or C++. We're going to be doing all our coding directly in the CG language, and I'm going to be explaining everything in here. And we're going to do our coding within this NVIDIA Composer 2.5 for the beginning part aspects of it. Once we hit a certain point, then we'll start switching into how to actually do this in C and C++, and how to load in these different shaders and effects and use these techniques and all this stuff. So, but for now, and it's not bad at all on the code for C and C++, but I just want to keep things simple and focused, and then as you understand each aspect to it, and we're not trying to cover several languages at once, and it's just not, just overwhelming. I want to keep things simple as possible. And besides, some people will never even touch the C++. If you're working with some of these other game engines that have already been developed or whatnot, you're just coding out the shaders and then you're loading them into XYZ program and importing them as a FX file. So you're not even developing the application where you're actually creating a shader pipeline. Chances are a lot of times those are already defined and developed by leads of the game company for lead programmers, and they're the ones who basically define and lay out the structure of the game engine, and then the lower level programmers, very talented no less, don't get me wrong, they're just not the lead programmers, do the other operations on the programming. So you might necessarily not even do the setting up the actual C++ pipeline as far as that goes for a game engine. We're going to go over it so you know how to do it anyways. You absolutely need to know that anyhow if you're wanting to be a game developer. But if you're just doing some programming for some shaders for XYZ game engine, then it makes sense to just focus on just the actual NVIDIA CG shading language, because you don't need to know all that other stuff for the meantime. You may find down the road that's useful to you, but definitely, especially when we start getting into some more of cutting edge effects and techniques and stuff like that, when you get into OpenCL or CUDA programming, it's very cool and allows for extra capabilities. And so, of course, we will have to go into C++ in order to do some of the next generation programming for the game engine development. Okay, so with that said, string is another data type here. And string is for, well, basically think about writing a sentence or a word or something like that. It's characters, more or less. And it can be text characters. Like, for instance, I could have hello Sally, whatever. So typically strings are contained within quotes. Hyperactive Studios. Oh yeah. All right. So there's Hyperactive Studios, right? So there's a string. Semicolon here for terminator at the end of the line. That lets the programming language know that, hey, this is the end of my code, end of the line of the code here. And that lets the compiler know where that where the line ends for that particular line of code. So that way it's not trying to figure it out or anything like that. It just sees the semicolon and goes, oh, that's the end of the that line of code. This is kind of cool because then you can actually span your code across multiple lines and then put a semicolon at the end to let it know that, hey, that's the end of the line of the code, and it'll get a better formatting to make things easier to read, and it just makes life easier. I can also put in numbers in here too, and other character symbols and things of this nature as part of the actual string text. So that's also something you need to be aware of. I'll go over naming conventions and things you have to do when you're doing these different data types, and what's required. Here we have a float 2 here. So we already talked about some of our floats. We're like, well, what does that mean? Okay, so a float 2 is going to be basically a vector of 2 floats. So this would mean that we'd have, think of it like, I don't know, x and y, for instance. Say we'd have 2 variables, float x and float y, right? So that'd be the x coordinate and the y coordinate positions. Okay, cool. But what they've done here with the float 2, float 3, and float 4, these are special vectors. Now, these, you don't want to define your own vector class. Like, you might be going, well, I know how to do my own vector class. I know how to code it out and all this stuff. Great. That's awesome. But don't do it. And the reason why is, no matter how optimized your code may be, it will not be optimized enough to match what NVIDIA has already done. And the reason I say this is because they have special hardware allocated out on the 3D cards for handling vectors. And this code here, when we create a vector, goes into that special space for that vector that's optimized for handling computations and moving in and out of the memory in such a way that it's as fast as possible. So no matter how good you do coding-wise, you will not be able to match what they've done, because they've gone through actual hardware acceleration at the development standpoint. From NVIDIA when they were coding out and developing this language. So use the vector types from NVIDIA for the CG language here. So and of course, don't forget that the just because NVIDIA wrote the CG language, this also works with ATI cards and the other cards too. So don't be thinking that, oh, this is only going to work with NVIDIA cards. No. It works with all the 3D cards. It works across the board. It works very well. It's very clean and it has very few problems. So it's very nice. It's probably the most all-encompassing solution I've seen yet. As far as shading goes, it's just really nice, and a bunch of game companies have standardized on this because it really simplifies life and allows you to develop things in a much easier manner. So that's a vector, so it'd be like your x and your y if you wanted to. Float 3 here would be, think of it like XYZ or maybe RGB or something like that for color. So this would be 3 variables together. You might be going, well, okay, but how do you assign values to this? Well, that's no problem. Say I was doing this as color, right? And maybe you've seen this from before, like, I don't know, the last video. As a for instance. This should look very familiar to you. Alright, so there we go. So I close my curly braces. And that's something to note. This is a curly brace and not a bracket. I think I said bracket in one of the other videos when I meant to say curly brace. This means open and close space here for containing these values here for semicolon. And this gets with the float 3. Oh, and on another note real quick. That is Control left mouse to move it and Alt left mouse to rotate it. I think I might have said right mouse plus Alt in the other video, and I meant to say left mouse click here with Alt. By the way, also if you hold down Shift and left mouse, it lets you zoom in addition to rolling your mouse wheel. Just a little another aside there. My apologies. And just as if I wanted to initialize a value, this is called initializing a value by basically fancy programming term for saying that we're going to assign these values when we create the variable, basically. So that the variable starts off with some kind of value. You might be going, well, why do I care? Well, quite frankly, if you don't assign a value to a variable when you first create it, then it has whatever value was just sitting there in memory. It's not 0. It's not just nothing. It's actually going to be a value that you just grab from memory. So that the computer grabs from memory. So you could get any kind of wild, crazy thing in there, and you will, guaranteed. So you do need to initialize your variables when you create them if you're not passing in variables from the program somewhere else or whatever. So that's important. Otherwise, you're going to have, who knows, unpredictable results, basically. That's what's going to happen. So it's a really good idea to have something there. So maybe this is going to be like, I don't know, that for there, and boy, my number typing here is getting interesting. Okay, and I don't know, I'm just typing random numbers here, just to get you the idea. Okay, and so there would be like, for float vector. Of course, if this is XYZ, I want this to be 1.0 for W. Okay, sometimes you might want to put spaces after this, and this is just for formatting convention. Why would you do this? Well, because it's easier to read. It's not going to cause a programming error or a problem, so doing certain things like this. I'm going to go over different formatting techniques for standardization and for programming here in order to make life a little easier and make things easier to read. The industry is very heavy about, in programming in general, period, about formatting your code to where it's as readable as possible, and it's just a professional thing to do. You realize you're going to have to be working in teams, and so if you're working in teams and working with other people, you have to be able to read each other's code. Not just that, you have to be able to read your code 4 weeks from now, and you come back to look at your program and go, oh my gosh, what on earth was I thinking? I can't find my code. You don't want to do that. You want to make your code as easy to read as possible. You're like, well, it takes me an extra 5 minutes to format the code. Great. Well, it's going to save you hours, maybe days on other things because, code wasn't formatted. I worked on a program a while back, some years ago, where a programmer literally had about 8 lines of code on a single line and started naming his variables, Z, ZZ, ZZZ, ZZZZ, Z, X, X, XXX, X, it's crazy. And you couldn't figure out what on earth one thing was from another, and he couldn't figure out in his own code. He had about 50 logic errors and several thousand syntax errors. I'll get into what that means here in just a second. But it took me about 2 weeks to format his code, and it was a nightmare. It was just absolutely ridiculous. and it immediately let me find a whole bunch of errors and made the program work and everything after doing so. So it's really important because there's a prime example, and the industry pretty much doesn't put up with that kind of stuff. If you do that, it's a great way to get fired. So don't ever do that. Make sure you write good, clean code that other people can read and you can work with a team, because you will be doing a team type programming scenario with like SVN or something like that, CVS or some of the other ones that a lot of companies use Perforce or Alien Brain for doing team-based programming. So rather important that you keep things clean and pretty as much as possible. All right, so we talked about a couple different vector types for these. And what about integer? Well, yes, we can also have ones for integer, like for instance, there we go. I'm going to keep that nice and even and clean. There we go. That would be a vector of 2 ints. Initialized to the value there. And again, initialize is what? Assigning the value when we first create a variable. So important. Here we have int3. So this would be 3 integers together in a vector. And then int4 would be 4 vectors, 4 integers in a vector. You can kind of see how this stuff is working. Half2 would be, yeah, I suspect you can guess it already. Yes, it's going to be 2 half variables as part of a vector of 2 values there. It should be 3 values. This would be 4 values. You just put the number afterwards. You notice I can't do a half 1. And you might be wondering about that. Well, what about half 1? There's no point. You have a half 1, it's just half. That is a 1. That's 1 variable in there. If you think about it, half 1 would be what? There it is. That's it. You know what I mean? That's all there is to that. So no point in having a half 1, because half is a half 1. So it would just be extra pain to code that. Have to type that 1 out there each time. And programmers are generally lazy in a good way, because you don't want to sit there and waste time coding stuff and doing stuff that's not necessary. So that's always an important aspect here. Fixed 2, as you can imagine, it's a vector of 2 fixed. And then a fixed 3 would be 3 variable of 3 fixed values. And then fixed 4 would be 4 fixed values for a vector. And then we get into these over here. And you're probably going, what on earth? Well, this is a matrix. And this is a 2x2 matrix here in float format. So what this allows you to do is create a way of bringing in, say, a matrix of some kind of value in there. So most of the time we're working with 4x4 matrices, and the reason why is because the math works out well when you do that. When you're multiplying them through with the scalars, as you should have seen in the previous videos here for the math series with the linear algebra. But if you're not familiar with this, just realize that this is a great way in order for you to bring in these values to work with the matrices. And an example of a matrix would be like the this worldview model view matrix here. And those are the matrices for doing those calculations for those transforms I was talking about in the earlier videos. And that'll allow you to, you can create your own transforms, your own, like an identity matrix if you wanted to, but they have identity matrices already pretty much programmed out as a predefined operation that you use on a regular basis, which is really nice. It certainly makes life so much easier. It's not even funny. But what we can see here is some other ways of handling some of this material, and we'll have a look at that. But basically this would be, for instance, like, oh, I don't know, something like this, right? Right, and then let's see here. Yeah. And I'm just going to keep this nice and clean. To where it's easy to read here. Alright, so say I had a matrix like that there. Of course it would move on me. He's trying to second guess me. Computers will do that. I'll move my cursor out of the way so you can read that easily. And there, for instance, is a 2x2 matrix. So you'd have, you know, these values across here, like so. And this basically lets you set up for this type of matrix. Now, if I'm doing an identity matrix, of course, I would have a different scenario here, right? Because if it's identity matrix, it's going to be like a 1.0 here, and then this one's going to be 1.0 across the diagonals. And it is good to actually lay out 1.0, lay out the stuff here in a clean manner. And an identity matrix is going to be zeros on these other parts here. I'm going to do identity matrix. Okay, so something like that, where it's going to be 1 across the diagonals and then, you know, 0 everywhere else in the matrix. You know, and this just makes life a little easier for handling this. Oh, cool. I can reduce that maybe a bit. There we are. So something like that looks nice and clean. Okay, and as you can imagine, you can do a 2x3, a 2x4, you know, 3x2, a 3x3, a 3x4, a 4x4, and so on and so forth for every combination of row and column you can imagine. And that lets you basically define and program out these different values. Again, you notice I don't have a semicolon here on this line because the line doesn't actually end until there for the line of code. This lets me format this out, makes it easy to read as a table instead of trying to visually guess what it's going to look like. And again, this is where formatting can make life so much easier because you can just take one look at it and recognize exactly what the matrix was going on with your X, Y, Z for translate, rotate, or scale. And if you're familiar with the mathematics on this, you can just look at it easily, and it just doesn't cause you any headaches really to see what it is you're doing. Of course, the matrices are extremely useful and used on a regular basis with this type of programming, for especially 3D graphics. So yeah, a lot of linear algebra is used in 3D graphics programming. Okay, so float 2x3, float 2x4 matrix. We can have a 3x2 float matrix, a 3x3, a 3x4, a 4x2, 4x3, a 4x4. We can't have a 4x1. Well, wait a minute. Why can't we have a 4x1? I'll show you. You can't have a 4x1. Can't have a 3x1 or a 2x1. Well, when you want one? Well, no, you don't need to because we have a vector. A fixed 4 here is a 4x1. So again, there's no reason to have a 4x1 data type. Now you may be going, if you're from C++ or C, going, we don't have vector data types and matrix data types in C. No, they don't. They sure don't. But this is extremely useful, and so yeah, normally you have to code out your own vector libraries, which kind of sucks, and also your own matrix libraries of functions and stuff in C or C++, and you know, with your own special easy to use operators for, you know, overloading the functions and all this stuff. I'm not going to get into all that. That's more detail for people who have been coding for a while in C and C++. But what you can have here with this is you can have these matrices directly, and again, this is optimized on the hardware to where you get very fast performance to do these calculations. And oh my gosh, does this make life easier because you're not having to, again, code out entire libraries of functions in order to make your own data types for this stuff, and you need it all the time. So this is something you just use on a regular basis, so it's just really nice to have this as part of the actual language. So there are some differences between CG and C++, although it does mimic C++ a lot. And if you're familiar with RenderMan or Mental Ray's shading programming, then probably recognize a whole lot of the shading programming if you're coming from a film side of things for post-production. Then, you know, this is not going to be all that shocking or new to you because you're going to be very familiar with a lot of these coding aspects and a lot of these techniques because it takes heavily from the RenderMan shading pipeline. If you're not familiar, RenderMan is from Pixar, and the president of Pixar wrote a good bit of it along with a lot of his people. It was at one point in time part of the LucasArts ILMs to be more accurate, Industrial Light and Magic, owned by George Lucas, which is his film division for doing Star Wars films, and well, just about every film out there practically has Industrial Light and Magic as part of the process at some point in time in the production. They're involved with so many films. It's amazing. But they're probably the biggest film company in the industry, quite frankly. I heard once a statistic of where they did 50% of the worldwide film production, which is amazing. Anyways, you have a capability here. At one point in time, well, basically Steve Jobs bought that Pixar basically from ILM. So the reason why they sold it off because they didn't care, because they already had basically their own render man in another part of ILM, and so they ended up basically having two render mans more or less. And so they sold off one of them, and that's what basically spawned Pixar, and it's been a great success since. But so yes, this language was based heavily around that, and in collaboration with Microsoft with their DirectX HLSL. So you'll find a lot of similarities with HLSL with CG programming language. And quite frankly, it's not all that different than OpenGL's GLSL. It looks a lot like it too. So once you know one shading language, it makes it really easy to move over to any of the others because they're all very much alike and are very similar. Okay, so back over to this again. Half is here we have a half 2x2 matrix, a 2x3, a 2x4, a 3x2, a 3x3, a 3x4, a 4x2, a 4x3, and a 4x4. And again, we have a fixed 2x2, a 2x3, a 2x4, 3x2, a 3x3, a 3x4, a 4x2, a 4x3, 4x4 for matrices here. And then yes, you can have integer matrices. Int 2x2, int 2x3, int 2x4, int 3x2, int 3x3, int 3x4, int 4x2, int 4x3, and int 4x4. Okay. Probably going, well, what about bool? Yes, we can do Boolean vectors too, by the way. So you can have a whole set of bools, which is true and false, if you remember right? So you can do this too. I should put this up with the other group. You're probably wondering, can I do a 2x2 matrix of booleans? Yes, you can. And you can do a 2x3, and you can do a 2x4, just like all the others too. It's nothing different. And if I want to sit there and copy and paste something real quick and easy, I can hold down Shift and then use my arrow key, heading down with the cursor in front of it in order to select it. Control C to copy it, and then paste, paste, paste. This just speeds things up significantly, so that way you're not having to, copy, find, replace is a motto of many programmers, as we are lazy and don't want to reinvent the wheel constantly. If you do, it's just ridiculous to do that, more or less. So let's see here. Let's just change this around a bit, and then we have our 4x4 matrix there. Okay, very cool. Booleans. So yeah, so you can do that too. And yes, you cannot do a vector of strings, just so you know, or a matrix of strings. So be aware, string is just string, so that's different. Something else you should be aware of for variables, and that is when you're defining a variable name here. For instance, here you see we're doing a matrix here, and we're naming it something here, and it's going to be passing in this value from DirectX or OpenGL here. Okay. Well, when you're doing your names, you have to follow standard programming naming conventions also in CG programming. So that means you cannot have a number before you have any characters. The reason why is this gets confusing to the programming language as to knowing whether or not you're trying to do some mathematics operation or something of this nature. So because that's confusing and it can't differentiate a number from a name, it messes it up. You can't do this. So you can't do something like 7 up, but you could do up 7. You can do that. Or you could type in 7 up is fine. Or you can do an underscore up is fine. You know, that's fine. You can do numbers after that very first letter. That's okay. You can do uppercase and lowercase letters. And typically, what you want to do, if you're going to do a struct or something of this nature, you typically want to make it uppercase for the first letter. And I like camel case naming conventions here. So say I want to do something like, oh gosh, I don't know, float here, and I want to make it equal, so I'm going to initialize it with something. Let's give it a name first. Let's see here, chord. Alright, coordinate. And then I'm just going to say, 3.4, for instance, semicolon. Alright, so this initialized a value to my new variable called chord, and it's a data type float. And it's going to assign the value of a decimal value, floating point value, to the chord variable here. And so what is this going to do? This is going to take this value right here, and on the memory in the GPU, on the card, this is going to place 3.4 into that memory location. And that's an important thing to understand. When you're running these programs don't run off the hard drive. They actually run in memory in a computer. That's why you have to have RAM in your computer. Just as such, you have to have RAM on your 3D card. Now, the more RAM you have, the more things you can compute, the more stuff you can handle. And you can get into some performance issues if you don't have enough RAM, because you can't. The GPUs are highly multi-threaded, a nice way to put it, and they can literally handle billions of threads at once. It's insane. It's crazy what they can do. Absolutely insane. And when you have a 3D card handling this, they can sit there and take these programs and copy it across multiple places in memory at once and compute them all at the same time. So you got to understand that when I'm writing this shader here, it's actually getting computed across all the vertices at the same time a lot of times, or all the pixels at the same time. And you're not doing like what you would do on the CPU, where you compute each vertex one by one, in succession, as you would typically do in C and C++. Instead, this is literally getting spread across the actual memory locations to be accessed quickly with shared memory into different buckets, if you will, into different places on the card, and being computed all at once simultaneously. So, if you will, this whatever little program we write in the shader, think of it as always being looped if you're familiar with C and C++. It's being computed many times across each vertex and across each pixel. So that's something important to understand, that these programs are going to actually get read across many locations at once. Another thing to note is a double slash like this means a comment. Now this is great. Commenting is awesome. It's something you should always do. Don't worry about putting in too many comments, because it's going to get taken out anyways on the compiled code with CG. They're going to NVIDIA's smart. You can have multiple names for stuff and have it assigned to make it more readable, and then when it gets into the CG code, when it compiles it down, it's going to automatically optimize it for you, which is incredibly awesome. So this means what? You can make your programs easier to read. You can make them clean and efficient for programming standpoint, and that's always good to do. So you definitely want these comments. You want notes to yourself as to what you're doing always. You never write enough comments, that's for sure. And you don't have to worry about that causing a performance problem for your code here. Now, if we go on up, you can see other type of comment here too. Now, a double slash is only comments a single line out to not be seen by the actual compiler, or for the actual shading to be used executed on the computer. It's completely skipped. If you want to comment out multiple lines to not be seen by the compiler, then you need to use this slash star. Now, if you're familiar with C and C++, it's exactly the same as C and C++ for its commenting system. And then in order to end the comment, that you're saying to the computer, okay, I want to start having the compiler not see this stuff here, and then I want to end the compiler not seeing stuff at this point. So / is going to end that. I can prove it real quick. I left this on purpose with these values here so it show up in blue to let you know that yes, this is qualified actual real terms that are acknowledged by CG. It does have color syntax highlighting for us. Syntax means it's a fancy programming term for just saying, hey, text in a file. That's what it means. It's just like if you were to write a paper in English, I mean, you're typing up your paper. Basically, we're just talking about text here. And it's just a fancy way of saying that. Okay, so every time you have a qualified, basically saying a legit name as part of the language, it's going to turn blue like this. Okay, so you know if you misspell float because it's not highlighted correctly. You can use the color coding in order to help visually check yourself as to whether or not you've made a typo. So it's very nice. If I do this, it automatically turns green because the computer is not going to see it anymore. Now, a compiler is what we're working with, a high-level language. This is not the code that actually gets executed. This gets converted into code that actually gets executed. And that's important to understand. The reason why that matters is because if you were to code at the level of the actual processor, it gets extremely complex. They're just ones and zeros on and off. It's a fancy way of saying it. Really, it's low and high electrical signals in the computer. The computer actually doesn't turn itself on and off constantly. It doesn't power down and power up. What it's actually doing is doing a low to high voltage variance here over the voltage that's going through the computer, and it's just moving that up and down really quick, super fast, in order to do quote unquote on off. On off is just a simplification of it, but that's essentially what we're doing on that. And then that's converted over to a language that's readable, that's at the exact same level as ones and zeros on off, high to low voltage signal. That would be assembly. So they do have assembly language for the 3D cards, but it's a pain in the butt in order to do the coding. So in order to make life easier, we code it in this high-level language. It gets converted from this high-level language down to assembly and then to ones and zeros. So it's important to understand that, and that's why I was saying you don't have to worry about the code, with these comments, because it gets taken out when it's compiling it down for the assembly level programming. So that's happening on here, and we've set up our compiling directives to tell it how to compile it, or what to compile, more or less. Okay, so with that, we've spent a good bit of time just going over data types. Let's move on to the next video, and we'll go further over the shader here and some other aspects of this, and getting into structs and some other things of the language. And that was data types for the CG language. My name is Nate Nessler for Hyperactive Studios, and thank you very much.